No, an explosion-proof device does not automatically make it a Class 1, Division 1 device. Class 1, Division 1 indicates a hazardous area where flammable gases or vapors are present in sufficient quantities to produce an explosive mixture, and the hazard is present under normal operating conditions. Explosion-proof means that the device is enclosed in a manner that prevents the ignition of an external explosive atmosphere by sparks, flames, or hot surfaces originating inside the enclosure. A device can be explosion-proof without being rated for Class 1, Division 1. This is because explosion-proof devices are designed to prevent ignition of external flammable atmospheres, but they may not be suitable for use in areas where the concentration of flammable gases or vapors is high enough to create an explosive mixture. For example, consider explosion-proof motors used in Class 1, Division 2 areas where the concentration of flammable gases or vapors is not high enough to produce an explosive mixture under normal operating conditions. Also consider explosion-proof lighting fixtures used in areas where there is a potential for flammable gases or vapors to be present, but the risk of an explosive mixture is low. Conversely, a device can be rated for Class 1, Division 1 without being explosion-proof. This is because Class 1, Division 1 areas may not always require explosion-proof equipment. For example, intrinsically safe devices, which are designed to operate at a low energy level that cannot ignite an explosive atmosphere. Another example is purged enclosures, which are filled with a non-flammable gas to prevent the formation of an explosive mixture within the enclosure. It is important to consult the specific product specifications and applicable standards to determine the suitability of a device for use in a particular hazardous area. To elaborate, let's define some key terms. A hazardous location is an area where fire or explosion hazards may exist due to flammable gases or vapors, flammable liquids, combustible dust, or ignitable fibers or flames. These locations are classified according to the properties of the flammable materials that may be present and the likelihood that a flammable or explosive concentration is present. The National Electrical Code, specifically Article 500.5, defines hazardous locations. These locations are broken down into classes, divisions, and groups. Classes define the general nature of the hazardous material present. Class 1 locations involve flammable gases or vapors in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations involve the presence of combustible dust. Class 3 locations involve the presence of easily ignitable fibers or flames, but not in suspension in the air in quantities sufficient to produce ignitable mixtures. Divisions indicate the probability of the hazardous material being present. Division 1 indicates that the hazardous material is present under normal operating conditions, or it is frequently present because of repair, maintenance, or leakage, or it might be present because of a breakdown or faulty operation of equipment. Division 2 indicates that the hazardous material is not normally present in explosive concentrations. It is present only in abnormal conditions such as container breakage or system failure. Groups classify the hazardous materials by their ignition temperature, explosion pressure, and other flammable characteristics. For Class 1 locations, these are Groups A, B, C, and D. Group A includes acetylene. Group B includes hydrogen, or gases or vapors of equivalent hazard such as manufactured gas. Group C includes ethyl ether, ethylene, or gases or vapors of equivalent hazard. Group D includes acetone, alcohol, ammonia, benzene, gasoline, hexane, lacquer solvent vapors, naphtha, or gases or vapors of equivalent hazard. For Class 2 locations, these are Groups E, F, and G. Group E includes combustible metal dust including aluminum, magnesium, and their commercial alloys. Group F includes carbon black, gold dust, or coke dust. Group G includes flour, starch, or grain dust. Explosion-proof equipment is designed to contain an internal explosion without causing an external hazard. The equipment's enclosure is designed to withstand the pressure of an internal explosion and prevent the propagation of flames or sparks to the surrounding atmosphere. This does not mean that the equipment is impervious to explosions. It means that if an explosion occurs within the enclosure will contain it and prevent it from igniting the surrounding atmosphere. Explosion-proof enclosures are typically very heavy and robust, constructed of materials like cast iron or steel, with tight-fitting covers and flame paths designed to cool escaping gases below their ignition temperature. Explosion-proof equipment is tested and certified by organizations such as Underwriters Laboratories, ORAL, and Canadian Standards Association, or CSA. The equipment must meet stringent requirements to be labeled as explosion-proof. An explosion-proof enclosure is designed to prevent an explosion inside the enclosure from igniting a surrounding explosive atmosphere. It does this by containing the explosion and cooling the escaping gases below the ignition temperature of the surrounding atmosphere. Intrinsically safe equipment is designed to be incapable of releasing enough energy to ignite a flammable atmosphere. This is achieved by limiting the voltage and current in the electrical circuits to levels that are too low to cause ignition. Intrinsically safe systems are typically used in instrumentation and control circuits where the energy requirements are low. Intrinsically safe equipment relies on the principle of energy limitation. The circuits are designed to limit the amount of electrical and thermal energy available to a level below what is required to ignite the specific hazardous atmosphere. This is typically achieved by using specially designed barriers that limit voltage and current. Purged and pressurized systems are designed to prevent flammable materials from entering an enclosure by maintaining a positive pressure of clean air or inert gas inside the enclosure. This positive pressure prevents the ingress of flammable gases, vapors, or dust. Purged and pressurized systems are used to protect equipment that is not otherwise rated for use in hazardous locations. There are different types of purging, including Type X, Type Y, and Type Z, each providing a different level of protection. Type X purging reduces the classification within an enclosure from Division 1 to non-hazardous. Type Y purging reduces the classification within an enclosure from Division 1 to Division 2. Type Z purging reduces the classification within an enclosure from Division 2 to non-hazardous. Encapsulation involves embedding electrical components in a resin or epoxy material to prevent contact with the surrounding atmosphere. This method is typically used for small components and is suitable for use in Division 1 and Division 2 locations. The encapsulating material must be carefully selected to ensure that it is compatible with the chemicals present in the hazardous location. Oil immersion involves submerging electrical components in oil to prevent contact with the surrounding atmosphere. This method is typically used for transformers and high-voltage equipment. The oil acts as an insulator and prevents the formation of sparks or arcs that could ignite a flammable atmosphere. Non-incendive equipment is designed not to produce sparks or hot surfaces capable of igniting a specific hazardous atmosphere under normal operating conditions. This type of protection is typically used in Class 1, Division 2 locations. The equipment is designed to minimize the risk of ignition by limiting the energy available and controlling surface temperatures. When selecting equipment for use in hazardous locations, it is crucial to consider the specific requirements of the location. This includes the class, division, and group of the hazardous location, as well as the ambient temperature and other environmental factors. It is also important to consult the product specifications and applicable standards to ensure that the equipment is suitable for the intended application. The National Electrical Code, or NEC, provides detailed requirements for electrical installations in hazardous locations. Article 500 of the NEC covers the general requirements for hazardous locations, while Articles 501 through 506 cover the specific requirements for each class and division. The NEC also provides requirements for wiring methods, equipment grounding, and bonding in hazardous locations. Other standards, such as those from the International Electrotechnical Commission, or IC, also provide guidance in the selection and installation of equipment in hazardous locations. These standards provide detailed requirements for the design, testing, and certification of equipment for use in hazardous locations. In summary, explosion-proof equipment is designed to contain an internal explosion, while intrinsically safe equipment is designed to prevent the release of enough energy to cause an ignition. Purged and pressurized systems use positive pressure to prevent the ingress of flammable materials, while encapsulation and oil immersion provide a physical barrier between electrical components and the surrounding atmosphere. Non-incendiary equipment is designed not to produce sparks or hot surfaces capable of causing ignition. Remember that selecting the correct type of protection is critical for ensuring safety in hazardous locations. Always consult the applicable standards and product specifications to determine the suitability of a device for use in a particular hazardous area. Understanding the differences between these protection methods is essential for anyone involved in the design, installation, or maintenance of electrical equipment at hazardous locations. Failing to select the correct type of protection can have serious consequences, including fire, explosion, and injury. Let's consider some practical applications. Imagine a chemical plant where flammable solvents are used. In areas where the concentration of these solvents is high under normal operating conditions, such as near a distillation column, a Class 1, Division 1 location would be designated. Equipment used in this area, such as motors and control panels, would need to be rated for Class 1, Division 1 and be explosion-proof. This means the equipment is designed to contain any internal explosion and prevent it from igniting the surrounding atmosphere, and it's suitable for continuous exposure to flammable vapors. Now, consider a paint booth in a manufacturing facility. While there's a risk of flammable vapors from the paint, it's typically only present during painting operations. This area might be classified as Class 1, Division 2. Here, explosion-proof equipment might be used, but it wouldn't necessarily need to be rated for Class 1, Division 1. The equipment needs to prevent ignition of the occasional presence of flammable vapors, but it doesn't need to withstand constant exposure. Consider an oil refinery. Certain areas with constant exposure to flammable gases are classified as Class 1, Division 1. Equipment like sensors and control valves must be rated accordingly, often using intrinsically safe designs to limit energy and prevent ignition. Other areas might be Class 1, Division 2, requiring different protection methods. In a grain elevator, combustible dust is the hazard, leading to Class 2 designations. Division 1 areas would have dust present during normal operations, while Division 2 areas would have dust present only during abnormal conditions. Equipment here must prevent surface temperatures that could ignite the dust cloud. Let's delve into some specific equipment examples. Explosion-proof motors are commonly used in areas where flammable gases or vapors may be present. These motors are designed with heavy-duty enclosures that can withstand an internal explosion without igniting the surrounding atmosphere. The enclosures have machined surfaces and tight fitting joints to contain the explosion. Intrinsically safe sensors are often used to measure temperature, pressure, and flow in hazardous locations. These sensors are designed with low-energy circuits that cannot produce enough heat or spark to ignite a flammable atmosphere. They are often used in conjunction with intrinsically safe barriers that limit the voltage and current supplied to the sensor. Purged and pressurized control panels are used to protect electrical components from flammable gases, vapors, or dust. The control panels are filled with clean air or inert gas to maintain a positive pressure inside the enclosure, preventing the ingress of hazardous materials. Explosion-proof lighting fixtures are designed to provide illumination in hazardous locations without causing an ignition. These fixtures are enclosed in heavy-duty housings that can withstand an internal explosion and prevent the escape of sparks or flames. Understanding the specifics of equipment ratings is crucial. Equipment is marked with various symbols and codes to indicate its suitability for use in hazardous locations. These markings include the class, division, and group for which the equipment is approved, as well as the temperature code, which indicates the maximum surface temperature of the equipment. The temperature code is important because it ensures that the surface temperature of the equipment will not exceed the ignition temperature of the surrounding flammable materials. It's essential to verify the equipment's markings to ensure it matches the requirements of the location. Incorrectly rated equipment could lead to a dangerous situation. When selecting equipment, consider not only the initial cost but also the long-term maintenance requirements. Explosion-proof equipment may be more expensive initially but can be more durable and require less maintenance in the long run. Intrinsically safe equipment, while often more complex to install, can offer significant safety advantages by limiting the energy available in the circuit. Proper installation and maintenance are essential for ensuring the continued safety of equipment in hazardous locations. All equipment should be installed in accordance with the manufacturer's instructions and applicable codes and standards. Regular inspections should be conducted to identify any signs of damage or deterioration. Any damaged or worn equipment should be repaired or replaced immediately. Training is also a key component of safety in hazardous locations. All personnel who work in these areas should be trained on the hazards present and the procedures for working safely. This training should include information on the proper selection, installation, and maintenance of equipment, as well as emergency procedures. Remember that the selection and use of equipment in hazardous locations is a complex and highly regulated area. It is essential to consult with qualified professionals and follow all applicable codes and standards to ensure the safety of personnel and property. Neglecting these precautions can lead to severe consequences. Let's reinforce the key distinctions we've discussed. An explosion-proof rating focuses on containing an explosion within the device's enclosure. It doesn't necessarily mean the device is suitable for environments with constant exposure to hazardous materials. A Class 1, Division 1 rating indicates suitability for areas where flammable gases or vapors are present under normal operating conditions. Equipment with this rating may or may not be explosion-proof, depending on the specific protection method used. In some cases, intrinsically safe or purge systems might be used instead of explosion-proof enclosures. Class 1, Division 2 rating applies to areas where flammable gases or vapors are not normally present but might be under abnormal conditions. Equipment here requires a lower level of protection compared to Division 1 areas. It's crucial to differentiate between these ratings to choose the right equipment for each specific hazardous location. Let's consider the practical implications of misapplication. Using non-explosion-proof equipment in a Class 1, Division 1 area could lead to a catastrophic explosion. If a spark or hot surface ignites the surrounding flammable atmosphere, the equipment enclosure won't contain the explosion, potentially causing widespread damage and injuries. Using Class 1, Division 1 rated equipment in a non-hazardous area is generally not a safety issue, but it might be an unnecessary expense. The equipment is over-engineered for the application. However, it's always better to err on the side of caution when safety is involved. Using explosion-proof equipment in a Class 1, Division 2 area is often acceptable and provides an extra layer of safety. However, it's essential to ensure that the equipment's temperature code is appropriate for the specific flammable materials present. In summary, the relationship between explosion-proof ratings and Class 1, Division 1 designations is not automatic. Understanding the specific requirements of each hazardous location and selecting equipment with the appropriate ratings are critical for ensuring safety and preventing accidents. Always consult with qualified professionals and adhere to applicable codes and standards when working in hazardous locations. It's about understanding the environment, the risks, and the tools we use to mitigate those risks. The goal is a safe working environment for everyone.